I still have to do one more.
Yeah.
But,
Oh, Zach has 3 more. Never mind.
but mine
No,
was
I have
still
2 more.
really fast. It's like 5 minutes.
Oh, that's right. Yeah, because he did.
Does anyone have an extra one of
Wait.
these?
Yeah, I need another one of those. I guess I'll just use the back.
That's what I was thinking before. Well, didn't I give you both of you 4?
We give you.
Because I made 12. I gave Zach's back.
Unless it's the board red.
Well, there's blank ones.
Okay, so we've got this grant. You come and sit down, please. Oh, where we going, man? We're in class. Get it. We don't have much time, so I know the desks are kind of messy, but if you can just grab everybody one of your graphic organizers, please. We're going to be doing a group activity today, filling in the rest of this graphic organizer to help you study for the final. So we've talked a lot about the visible light spectrum, right? Can everybody point to the visible light spectrum on your graphic organizer? Okay, and where does light come from, David?
Energy.
Energy, right. So there are other transmissions of energy, aren't there? If we heated up a piece of metal or something and got it really hot and it would look red, how would your brain know, warning, this is dangerous?
Because it's hot.
Because you learned that red things get warmer, right? And what we learned from Herschel yesterday in his investigation of light and finding something that wasn't even there that we didn't know about, he discovered the infrared spectrum. So where do you think that is in your graphic organizers? To the right or left of the visible light spectrum?
Left.
So there's some things that are missing here, aren't there, in our graphic organizer? There's some boxes that we're going to fill in. Lanny, where do you think red's going to be, infrared is going to be in our spectrum there?
To the right.
Okay, everybody's saying to the right. Why would you say right when we see red on the left of our graphic organizer? Remember the colors of the rainbow? We filled that in already. Infrared. Think of the word infrared.
Would be next to red, right?
Next to red. Very good, David. So, yeah, I see you've already written there. So we're going to do this as a group, okay? Does anybody ever wondered why when you're going through a tunnel in your car and the cell phone cuts out but the radio doesn't? Does it ever happen to you?
Sometimes radio does too.
Okay. So that's one of those transmission things that happen, right? Energies can't go through certain things. Light goes through glass, light can't go through solid things. So where do you think radio and microwaves are, because cell phones are transmitted through microwaves, are on our spectrum here? If it can't go through glass, right? If it gets interrupted from tunnels and stuff like that? I think to the left or to the right?
To the right?
We're heading to the left here this time, Grant. All right, so the radio cuts out, or the cell phone cuts out, but the radio doesn't. So which one is closer to the visible light spectrum? This is a qualitative aspect of information transfer. Okay. I'm going to go ahead and give this to you guys. I'm going to put this down on the table. This is a pre-made graphic organizer that talks about some of the size of waves, and it also gives us where they lie in the spectrum. So go ahead and just copy that down in your spectrum, your handouts, your graphic organizers, because you're going to need this information. And I want everybody to think about other kinds of waves that you may have been in contact with. From that list, has anybody ever had any experience with any of those other waves? David, share at your table.
I-
Talk with your partner. Do a little
I've had a
table talk.
couple X-rays
Yeah.
done.
Same here. And,
Oh,
I use
yeah, I
the
guess I put my
microwave.
teeth sometimes.
Oh,
Yeah.
too.
I listened to the radio.
No, Gamma Ray because Incredible Hulk.
Yeah.
That's how he was pretty much created.
yes.
That's all I know about that. Though. I actually don't understand anything else about it other than that. The Incredible Hulk.
Okay, so as scientists, we investigate these phenomena, right? We didn't always have X-rays. We didn't always know about infrared. And so we have to take some steps to understanding these ways in order to use them in the right way. I hope I hit record.
I didn't really think about that. It's recording.
So this is kind of our closure activity as well. How can we, as young scientists, learn how to understand these ways and use them for our own applications? Are there some inventions that you can think of that you might want to use to make life easier? X-rays have a very good application in reality because they show us where our bones are broken. X-rays can penetrate our skin, but they can't penetrate our bones, and that's the shadow that's left over. The Incredible Hulk uses, what did you say, gamma radiation? I'm not familiar with the...
That's how he was made. I don't think he uses it, but that's how he gets his powers.
Okay.
Yeah, power. That's what it is.
So there are some other boxes that everybody hasn't filled in yet. Where are the higher frequencies, the more powerful waves, right? The more, go ahead and fill those in. You can just put Hulk or building or, you know, a building is kind of hard to stop, isn't it? But so is the Incredible Hulk.
That is very true.
I want you to think about how you can use these waves. Radio waves, they're so large, can go through tunnels when microwaves can't. They get reflected off of things more easily. They can't transmit through. All right? So does everybody feel good about this so far, so we can take us to the next step and use some of the concepts that we've learned to apply waves in new ways? Give me a thumbs up or a thumbs sideways, or like, I still don't get it and I need more help. Some sideways, thumbs up? Okay, thanks everybody. I know this isn't very much time, but